Hi everyone, welcome to week 4 of our Meter Maker series. We are once again joined by Faye as co-host. Yay!
Hello.
Hello! And this week we are meeting Andrew Barth. Hello, Andrew.
Hello, how are you guys?
Very well, thank you.
Having such a good day, and it is perfectly rounded out with the presence of your two lovely faces. I'm so happy to be here again.
Aw, you're so lovely. I love it. You feel all sparkly.
Absolutely. And I'm so happy you're here, Andrew. Oh my God.
Me too.
I feel like I have known for some time about your awesomeness, and I feel like today we finally get to show a few more people your awesomeness, and I'm super pumped about that.
Thank you.
Definitely. Quiet achiever over here. Show you off to the world.
Absolutely.
Thank you.
Well, I mean, let's jump in. I want to know more, but basically, one of the things that you think you're most well known for. If somebody's heard of you, or if somebody's seen something you've done, what would they know you for?
So I think really the only thing at this point would be Project Egress, which was the collaboration with Adam Savage, Jen Schachter, the Smithsonian, and a bunch of people.
So cool.
I mean, that's a big deal. So
yeah, it was a lot of fun.
Casually,
yeah. It's no biggie.
So cool.
Yeah. So basically what I did on there was I was the CAD modeler for it. So I took the 3D scans from the Smithsonian and made a big CAD model of about 750 parts or so initially, and then it grew to 1,200 parts. And then we sent out all the drawings that I made to a bunch of different makers around the country, and then we assembled it in DC. So yeah, there was a bunch of individual videos and tested, put out a video, and I think there was a live stream and whatnot on the Air and Space site. So that would probably be the most attention on the thing that I've done. Yeah.
And
I definitely think a link to the project should be down in the description, because it's really properly cool. If you haven't seen Project Egress, you have to check it out.
Yeah, and for anyone who hasn't, it's recreating. It's a celebration of the makers that got people to land on the moon, right? Am I saying that correctly?
yeah, absolutely.
Okay.
So the original Apollo program was around, I think I might be wrong, but I think it was around 400,000 people working together from all over the country, doing all kinds of different jobs, from textiles to machining to actually sewists and needlepoint artists making the memory on the Apollo guidance computer. So all different kinds of skills being brought together to achieve one goal. And so we kind of did a very mini version of that, where we had different artists and machinists and makers do the similar thing on a smaller scale as an art piece.
Very cool. That's awesome.
So cool.
And were you retro engineering from the scans from the Smithsonian? Did you use those as a guide and then rebuild them in Fusion? Or something?
Yeah.
Was it Fusion?
Exactly. It was Fusion, yeah.
Yeah, okay.
Yeah.
Yeah.
So they sent me the 3D scan, and basically I did point-to-point measurement on a bunch of different features, all of the features pretty much on the hatch, since it was all one piece, since the hatch was assembled at the time. Still is, to be clear. They didn't take it apart.
Good.
The scan came in as one mesh, and so I had to kind of break it up into individual parts in my CAD process. And yeah, it was a lot of tedious work, but it was a lot of fun.
Yeah.
I did have
a master reverse engineer, aren't you?
It's becoming a little bit of a trend with some of my other projects, yeah. But
talk about those. What other things do you do when you're not recreating spaceships?
So actually, what got me into Project Egress was a friend of mine, Ryan Nagata. He's a friend of Adam's, and he's been on Tested, whatnot. He makes replica spacesuits for movies and for different people, and people like Adam, who has his own Apollo suit and Mercury suit and all that.
As you do.
Yeah, just
as you do. As I hope to. So I messaged him one day, and we kind of got talking about doing some replica work. And that was about 2 years ago. I think that was September of 2 years ago. And so this is what we started working on first. This is an Apollo neck ring from the spacesuit. So what it does is it goes over your head. I don't think it will fit on my head with headphones, but it sits on the spacesuit itself, connected to the spacesuit, and then you have your helmet that actually keeps all the pressure in. So when you want to actually, yeah, if you want to survive, so what you do is you take this and you take the helmet and you just put them together. There's a whole mechanism. There's a bunch of pins that lock the helmet in place. You can kind of see some of those there. Basically, yeah. So I actually just finished those today. I was just at work doing some lathing for some pins that you can't see inside, but I wanted to show it off for this.
It's very
casual lathing.
Casual lathing.
Just casual lathing, yeah.
No big terrifying.
No big deal.
Yeah.
That's awesome.
So the fun thing about this is actually anodized aluminum, like the real ones. So we went for as much accuracy as we could. We didn't get the same grade. I think the original ones were 2024 aluminum, and we're using 6061. I mean, like, it doesn't make a difference for us. But just for those who are curious. But it actually moves. So you can actually unlock it, and if you see all those pins have retracted.
Oh, yeah.
And when you move it back, they all pop out again.
Right, and that they would hook under in some lip or something, and that's so cool. Wow.
Exactly, yeah. So
this is proper functionality.
Yeah.
Yeah.
And you
There's actually I did, yeah, infusion. So I had some resin castings of the originals that Ryan had sent me, and so I just kind of measured things and hoped, and it actually ended up working out. So what's really fun is that Adam had said in a couple of videos when he was showing off his neck ring, which is the same thing. He said that the helmet is so accurate that it would actually fit in a real spacesuit, and I hadn't confirmed that at the time, but I did. I actually went to ILC Dover in Delaware and got to play with a real spacesuit that they use for testing, and I fit a 3D printed version of the helmet ring into the real version of this, and it fit.
Oh, that is so cool. Best reverse engineer ever. That's incredible.
Like I said,
holy moly.
Master reverse engineer.
Master. That's amazing. Like,
just
first go, boom. That's incredible.
Fine, just totally works.
The mechanism's really interesting to me too.
Amazing.
Like, are these CAD models online somewhere that people can access, or are they?
No. So this is a lot of research done by my friend, and for now, at least, he wants to kind of keep all the hard work he's done to himself. I totally respect that. I would most likely do the same. I can show you kind of what the mechanism looks like because there are photos online of that.
That'd be cool.
Yeah. So this is a 3D printed version I actually did before I built the real one, or before I had the real one built. I didn't machine that, to be clear. I just made some of the pins. But I did print this ring off. To just kind of check if I made any dumb mistakes, like if I didn't look at the model closely enough and there's like a bunch of interfering parts or whatnot. But basically there are two rings.
Print too.
Yeah, it was on the CR10.
Super clean.
Yeah. So basically you have a bunch of these holes that go through. In the real one, these are actually blind holes from the inside, so I'm not really sure how they did that. They'd have to have like some kind of drilling head come in and do some precise. I don't know. They're wizards back then because they did this all manually.
Oh dang!
Basically, you have those pins, and then you have a pin that goes inside the other pin, and that pin has a head that rides into these channels right here.
Oh, I get
They're actually carved into the top. Yeah.
Okay, and as you turn them, it pushes them close. Yeah, wow.
Exactly,
genius. I love it. Wow.
Yeah.
Engineering at its finest.
Oh, so cool. Mechanisms just get me going. I just love them. It's very cool.
Right? Yeah. Yeah.
We're all such good nerds here. Such proper nerds. Getting excited about functional mechanisms. Look at us go.
It's like that website. There's like that website of like 500 and something mechanisms or whatever.
501 or 503 or whatever. Yeah.
Yeah. I just like browse it sometimes. I'm like, wow, neat.
Especially the animated ones.
Yes. Oh my god.
You get the same action movie. You're like, ooh.
Yeah. It's also kind of
that is nice.
calming. Like there's something very kind of like deeply satisfying about it.
Mm-hmm.
Just feels.
It does. It feels good.
Okay, so besides reverse engineering, you're clearly incredibly skilled at. Like, what are some of your favorite skills? Like, what are some of your favorite skills or techniques, stuff that you've kind of picked up along the way?
Yeah, so it kind of goes along with some of that stuff. Back in high school, I think it was my freshman year of high school, I decided to learn G-code, just like the basics of G-code, which is what you use for CNC machining. So we actually had a plasma cutter at the school that was a CNC plasma cutter. And so I had some extra time.
Different at my school. Barely had computers there.
So it was actually a student that built it a couple years before I got there, which is even cooler.
Wow. Okay. Amazing.
Yeah. They basically took one of the handheld. Yeah. They basically took one of the handheld ones and bought the end for like a CNC version, but then they made the entire frame and all the motor controls and whatnot themselves, and used Linux to control it.
Dang.
Yeah, it was super cool.
Wow.
Dang,
so I got to play with that.
That's very cool.
This explains a lot, I think.
Yeah.
Like having access to that sort of kit from a young age, I can only imagine would be formative.
Yeah, especially with the fire aspect of the plasma cutter.
Yeah, I'm so surprised. Like, are you talking high school? Like,
yeah.
Wow.
Yeah. Yeah.
Would not trust yet 9 boys with a plasma cutter myself.
So we actually had a full weld shop too.
Wow.
So we'd actually learn how to do proper welding. And there was an option to get certification for welding at one of the local like community colleges. I never did.
Hey.
I was not that good, but like that was an option at my school.
That's so cool.
I was super lucky.
Yeah.
Wow.
It was a huge privilege.
Is that where your fascination in like aeronautics and stuff came from, or is that the right?
No. So I was very interested in airplanes since, well, for as long as I can remember. One of my earliest memories is, I think it was a B-2 bomber flying over my head on approach to land, like on final for landing at an Air Force base that was nearby. And so that was very formative. And then my dad was also a private pilot, and he was interested in space, and still is. So like he went to see Apollo 13 lift off in person. He drove from Illinois down to Florida to do that. So like that's kind of where I came from. And then he kind of encouraged me to follow whatever I was interested in, which happened to be space and airplanes and stuff as well.
Very cool.
So that's incredible.
I basically always wanted to build airplanes as long as I realized that they could be built by people instead of just like some machine factory. Yeah. I mean, when I was 4, like I didn't understand like airplanes are hand built basically.
Yeah.
When you're a kid, I think everything is just kind of suddenly exists. I don't think you reach a point where it suddenly occurs to you that like things are made by people
the water in the tap
machines
comes from
or what have you.
Yeah.
Yeah, exactly.
A 747 doesn't just appear.
Yeah.
Exactly.
And then it just becomes even more fascinating, I feel. Like, I remember standing on the top of a building. I was working on a job site, a big hospital, and I remember standing on the top. And just, like, it dawned on me that every single thing that below me was, like, planned and bought and organized to come in on transport and then assembled, all in a relatively correct order in order to be able to make everything I was standing on. It just, like, blew my mind what humans can do all together. Like, it's astounding. We're freaking incredible as a species. Like, what is that? That's amazing.
It is very cool. And that is why civil engineering is such a crazy job, because like there's such an incredible amount of planning and that goes into that sort
and
of thing.
then getting people to
really,
the
really
freaking
cool.
moon
Get that.
is like a whole other level. Yeah, it's
Yep.
amazing.
Yep.
Yeah.
Whole other planetary body. Like,
Mhm.
yeah. The
Yeah.
humans are incredible, and I think it's actually really easy to forget that. Like I definitely think we take for granted like the stuff that goes into like building a hospital or an airplane or engineering a vaccine, or like all of these various things take so much more skill and time and effort than I think we really think about on a daily basis. So yeah, make you think.
Yeah, definitely.
Definitely.
And is that still where you draw your inspiration from, like the passion you have for space and planes and stuff, or are there other places you draw inspiration from in your works?
Yeah, so I mean, like, there's like historical events like landing on the moon and big flights and all that. And then there's also like other people. One of the YouTubers that really got me, really kind of made me want to be better at making things was ClickSpring. I'm not sure if you guys have. Yeah,
definitely amazing. His anti-Kethra mechanism.
Yeah.
I'm with
you. It's incredible. Especially with the Antikythera mechanism. Not that the Skeleton Clock project wasn't cool, but like he's doing the Antikythera mechanism by hand. Like he's making the files to make the teeth on the gears. It's just,
like working out whether squid ink is better than charcoal black in order to be able to I'm like, you were just another level, mate. Like,
yeah, he really is.
Yeah.
So yeah, people like that, people like Adam, people like you guys. Whenever you guys make things, I'm just like, oh, look at that.
So nice.
Yeah.
Oh, that's so broad.
Yeah.
Broad influences.
Yeah. Yeah. I'm just inspired by the world.
Yeah, I feel that.
That's very, very fair. The world is awesome and inspiring in so many ways, which is, I think, part of the reason why we're trying to focus on some of the cool, inspiring people in it.
Yeah, exactly. Like, I'm the same. I find so many people inspiring, and that's exactly why I wanted to do this, because there's awesome people like you, and like, yeah, it's just so cool to be able to hear what makes you tick. I don't know. I love it.
No, it's very gosh, what's the word I'm looking for? Noble. This is a very noble pursuit in bringing people together and sharing their stories and sharing the inspiration. It's very noble.
It's a noble cause.
Oh.
Yes, noble cause. It's a noble cause.
Totally selfish, because I just love hanging out. So
fair enough. Also,
that's a bonus, you know. It's the cherry on top.
Definitely.
So, when you are creating something or doing something, or just when you're making something, what is your workflow like? Like, what's kind of your creative process, and like, do you have a favorite part of it that you would like to share, that in particular?
In general, it's a mess. Especially, so like the biggest project I've done so far is Project Egress. As far as like volume of parts, especially. So when
you did say 750, that's a lot.
750 and then 1200. Once I made the gearbox work, I honestly found new ways to crash Fusion, and it kind of stumped the Fusion team a little bit.
I'm
that's right. You mentioned that one.
By that. Yeah. I don't think I've made that many things total. Like,
I think Sophie Wong was starting to run into the same problems when she was making the 3D printed dress, because there are so many individual parts. Yeah. I think she hit way more than I did, but yeah, it was a lot of fun. But basically, I start off freaking out the whole time. So like when I see the hatch, I'm like, no, and then I slowly calm myself down, and then basically I try and think of how to split it up into manageable parts. I've drawn some inspiration also from aircraft builders, people who build like kit airplanes at their local hangar, at their house or whatever. It's a whole airplane that you have to somehow eventually fly and not die in. So you better do your job right. But you can't be thinking of that really the whole time. You can't be thinking of all the 4,000 rivets or whatever, 10,000 rivets in the airplane. You have to think, okay, I have to make this part right here, this big, perfectly. And that's all I have to worry about right now.
So you kind of isolate a section.
Exactly. So, like with the hatch, I started with the main kind of base frame of it. I didn't think of any of the things attaching to it. I just said, okay, there's a bunch of stuff on here. I'll start with the front. And I'll start with a big cutout in the window because that's a big thing. And then I'll add details as I go. And then eventually I was done with it, and I moved on to the stuff that attached to it, and did the same thing. There's a saying in like aircraft building. I don't think it's unique to aircraft building, but it like poses the question: how do you eat an elephant? Which, like, is the gigantic task, and you eat it one bite at a time.
One at a time, yeah.
Yeah,
yeah, it's a good one.
Yeah,
absolutely.
I've never eaten an elephant, but I have broken a big project into small parts and managed that way.
Yeah.
You've eaten a metaphorical elephant.
Yes.
Yeah.
Just not a real one. Which is probably for the best.
Yeah.
Probably,
definitely for the best. This is much better achievement than eating an elephant.
Yeah. Yeah.
I would agree.
I definitely agree with that.
Uh-huh.
I'm actually really pleased though that you and again, like I think one of the things that's been really nice so far, even just in this segment that Billy's doing is the fact that people are being honest with their process, and something like sharing that, that you have a moment of freaking out a little bit at the beginning. I think that's so relatable. That's so incredibly relatable and really important, because I think that it's very easy. I feel like I've mentioned this on a previous week even, that it's very, very easy to look online and just see everyone being really, really polished and perfect all the time, because that's how we present ourselves on social media. And I think it's actually really, really good and very important to be kind of being honest, both with ourselves and with everyone else. And it kind of like, yeah, the first part of my workflow is I freak out a bit, and then I take a nap. And then I come back and, like, I don't know, just thank you.
Make myself some food.
Thank you for being honest and helping to demystify some of this stuff a little bit, because I think that every person who comes on here or anywhere and kind of talks about their process in an honest and realistic way will help so many people to feel a little bit more normal, I guess, in their own worries and concerns and freakouts. So,
yeah.
Thanks.
Yes.
A similar thing happened to me with one of the videos that Adam was making with Tested. He was making some spacesuit parts for his spacesuit, his Apollo spacesuit. I think it was like a dosimeter and some valve things and a perch port or something like that. I don't know. I actually don't remember. But he kept messing up these parts over and over. And they kept it in where he made the mistakes and he had to start over again. And then eventually he just went home and, had dinner and just like slept on it. Yeah. And he came back. He was talking honestly. He was saying, like, honestly, I was saying to myself, you have no business making things. Like, this is Adam Savage, who's like, great. He's a wonderful person. And he's also really good at making things. It's almost like he's a professional.
Yeah. He's got so much experience.
Almost like it's his entire career.
Almost.
Yeah.
But like when I saw that even he was like having the similar thoughts that I do when I mess up things, I was like, okay, maybe this isn't just me.
That's why this is so important.
Maybe this is
Maybe this is everyone and part of the journey and all of that. Yeah.
Yeah. Maybe we should also be nicer to ourselves.
Yes, we do. We need to be kinder to ourselves. Yes.
Also that.
Seems to be a recurring theme in the maker community. I don't know many makers out there that are just like, I'm freaking incredible, the end. Like, we all seem to have moments of vulnerability and, doubt about ourselves. So it's good. These conversations are great.
Yeah.
It's good. We're human.
Yes.
Yeah.
Mm.
We're
Yeah.
human. I've tried to not be human and thus far unsuccessful.
Yeah.
So like it might be better to just accept it and embrace ourselves for our human side.
And do you find in your creative process, are those moments the biggest struggles, or are there other things you find difficult in your creative process?
So honestly, I'm just gonna assume that I'm being honest.
Yes.
Yes.
Yeah. I have a really hard time focusing on things sometimes. So like I have a big unfinished project that I started before Project Egress, and I still haven't finished it. I haven't really worked on it at all since then. And it's something I wanted to do for years, and then I just kind of like left it. Staying focused, getting back on a project is really hard for me.
I'm the same. Once I put something down, it doesn't often get picked back up again. If I can't finish it in a day, it might not ever get finished. Yeah. I
think this is something we can all relate to here.
Yeah. I have actually two examples of that. I have a Tesla coil, a solid-state Tesla coil that I'm building. And I also have a jet engine I designed and building, but I haven't really worked on that recently either. And I can show those both if you like.
You did work on it a little a couple of months ago, though, didn't you? I swear you said you'd made some progress on one of Matt's calls.
Yeah. So actually, it wasn't me that made progress. It was a friend of mine, John Saunders. He had machined a thing for me, and I received it.
Well, that's a kind of progress. I'm calling it progress.
Progress.
I need to make a new combustion chamber assembly and a new way to deliver fuel to it, and I just haven't gotten around to that.
That's so cool.
Although now I just got training on like mills and lathes and stuff at work, so I'm now allowed to use that. So I might, maybe, no promises,
leveled up,
start doing stuff again.
That's very cool.
Now, in your defense, your projects sound massive.
Yeah.
Like sometimes my projects are like I'm just gonna make a little thing and that'll be it, and that's the whole project. You're like designing a jet engine.
Yeah.
That sounds big.
Maybe? Well, maybe. Yeah, I guess.
So in your defense, I feel like these are projects that realistically would take an extensive period of time anyway. So, and then you've got other stuff going on. So, yeah.
Like, I have a career now, which is weird.
Yeah.
Love a good career.
That takes up some time.
It's amazing.
Are you enjoying it?
No.
Yeah, I really love it. I get to work with airplanes every day. Like, I walk into a building. It's just like a hangar at an airport. And there's like an office space, and then you walk out the door into the hangar, and like there's just an airplane there. That like you're partially responsible for designing stuff on, which is really fun. And then like every day or every other day, there are F-18 Hornets flying around from the local air bases. It's like they'll just fly by and land and then take off, and yeah.
Sounds dreamy. It sounds dreamy.
Once in a while, about once every week. Yeah. About once every week, you hear a sonic boom as well from the supersonic corridor nearby. So you just kind of hear like a thump. You're like, was that a car door or was that an airplane?
Probably good it's not too much louder, though. You might damage radius.
So
I love
really
how
weird.
It's everyday occurrences for you. It's weird stuff, but it's just an everyday occurrence for you.
Yeah. So I think it was my second day. I was in one of the hangars for training. Because one of the first things you do is, as an engineer even, you go through composites training. So you actually learn how composite structures are built out of fiberglass and carbon fiber. And you do the mixing of the resin, you do the layups and everything. And that's super valuable, which is why I love that company. But we were in that hangar, which has gigantic hangar doors. And the doors just shook. And like I heard a really low sound, but like most of all, I heard the doors shaking and like moving and stuff. I was like, what the heck was that? And they're like, oh yeah, that was a sonic boom. I'm like, excuse me.
No one told me that would be sonic booms.
Like, I suspected,
The fact
but
that you
like,
live somewhere where
come
there's
on.
earthquakes, like that would be a concern. Like,
Yeah.
dang,
That's
you
pretty
think someone would have clued you in?
Yeah. You could have been running for cover and
By the way, FYI, sonic booms may happen. You know, like. Hey. Well, I want to know. If you. So you're doing some really incredible stuff. If you don't mind me saying as well, like you've done such amazing things, and you are still so incredibly young to have done such incredible things. So, do you have any advice to give to people who might find themselves kind of following in your footsteps, having with similar interests, maybe wanting to do what you do? Do you have any advice for them?
wisdoms from Andrew.
So I honestly have a ton of privilege. Like people that had no business paying attention to me paid attention to me, like Ryan and Adam and you guys. So like most of it is that. But I mean, as far as project advice and whatnot, and general making, I guess just do what you can with the tools that you have. So for a while, I didn't really have much extra money or anything because like college, and so I just kind of did my best to get the tools that I could and make what I could with that. And you can go surprisingly far with just that. Especially like going back to ClickSpring, he uses files and he's building an Antikythera mechanism. Like you can do a lot with really simple tools. Obviously 3D printers and all that CNC equipment is a lot more expensive, but if you need, you can join like a local makerspace, and it'll definitely bring down the cost. I don't know. I basically would say, yeah, do what you can, and don't be afraid to contact people that you don't think would ever pay attention to you, because they just might send you some spacesuit stuff and offer you a project with Adam and the Smithsonian.
That's fantastic advice. That's really good advice.
I've given the same before too. Just talk to people. Who knows? They
Yeah,
might talk back.
Yeah.
It's lovely when they do, and you like get to definitely. I would totally agree with that.
Like recently, I walked up to Dick Rattan, who's Dick Rattan and Bert Rattan founded Scaled Composites, and did like all kinds of home build airplanes and whatnot back in the 70s, especially with composites. They were kind of the first. I think they were the first home build composite aircraft.
Wow.
And they're all over the place at fly-ins and whatnot. Yeah, they're super cool. They're also weird looking. They don't have like a wing and a tail in the back. They have a wing in the back and canards in the front, and the engine in the back.
Okay, I was like, that's a really odd thing to say, but all right.
So, I think I need to see it. I'm like, sounds like it's like falls and misses.
Oh.
So actually,
plane. No tough now.
Yeah, it's weird. It's called a. So one of them is called the Long Easy, like the letters E and Z, and then there's another one called Very Easy, and the Burkut and all kinds of stuff. But yeah, they all look weird, and especially in the 70s, like no one else was flying any kind of configuration like that. So it was like, what the heck is that thing in the sky?
How does that work?
Yeah.
Something Bernoulli's principle.
Navier-Stokes somewhere in there, you know.
Yeah.
But yeah, I mean, like apart from the airplanes being really interesting, they've done a lot of incredible things. Like Bert started Scale Composites, who eventually built Spaceship One and Spaceship Two. That Spaceship One was the first private individual to fly into space, which was wild. That was back in 2004. Wow. And then Spaceship Two has been doing stuff with Virgin Galactic and all that. But back in the 80s, I should know this because I worked there, but I think it was the 80s. Dick Rattan and oh my gosh, I forget her name. I am an awful person. Jenna Yeager. They both flew around the world in a single tank of gas, basically. They didn't stop, they didn't refill, they just flew around the world. From Edwards Air Force Base to Edwards Air Force Base.
That is incredible.
Yeah.
Wow.
Yeah.
When was that? In the 80s.
I'm going to look it up because I'm going to be wrong. But yeah, it was in the 80s, I believe. It's called Voyager.
I mean, that could have been done last week and I still would have been impressed.
That's incredible.
Yeah.
Wow. So was the plane custom, really lightweight or something? Really good winds that time of year? I don't know. That's amazing.
Yeah, so I'm sorry, I'm just looking it up because I want to know. 1986. Yeah.
Wow, that was the year I was born.
Hey, that's so cool.
That was a little while ago.
So yeah, they built this thing called Voyager. It also has a weird configuration. It's not like any other plane that you've probably seen. It has a big, very thin wing in the back. And then it has two booms on the side and a fuselage in the middle with two engines, one in the front, one in the back, and it has canards in the front. And so it's this really high aspect ratio wing, it's called. So if you had this as an airplane wing, this would be a low aspect ratio as far as length to chord. So this is flying forward or whatnot. Whereas a high aspect ratio wing would be something like this, where you have a really thin chord but a long wingspan. Voyager was a high aspect ratio wing. I think it was something like 20-1 or something, 20 times the length. 20 units of length to 1 unit of chord. It was big.
Must have been made out of some really strong stuff then.
Yeah, fiberglass, and I think it was mostly all fiberglass.
Wow.
As we're learning, fiberglass, that's basically...
It's amazing.
That's the thing.
Yeah, wow.
That is the thing.
That really is mind-blowing. I didn't even know that we'd done that as a species. That's cool.
Yeah.
Wow.
So I think they did that again in 2005 with Global Flyer, which Scaled also built. I think it was a similar mission. I think it was only one pilot though. But yeah, both of those are hanging in the Smithsonian. And when I was there last summer working there, I didn't appreciate them and what they would mean to me in the future. Because I wasn't even talking to Scaled at that point. And now I met people who made those.
That's incredible.
Which is really wild.
That's so cool.
Yeah.
Wow.
Now you just got the coolest job, and I'm still remembering what you told me earlier about the Expanse too, which is just the coolest little Easter egg.
What?
I'm gonna go ahead and tell it. Yeah. So yeah, I was rewatching The Expanse. I don't know. Have you seen that, Billy?
It's an amazing TV show that everyone should watch.
Yes, yeah.
If you like sci-fi even a little bit.
Yeah, it's great.
Yeah.
Oh god.
So I'm not gonna spoil things. I don't think. But there was this ship.
Wait.
I'm so sorry. That was my alarm. I forgot that this was going to take part during when my alarm would. I'm so sorry.
No, you're good. You're good.
That was hilarious. That was very funny.
Please.
I was like, oh, where'd she go?
Sorry.
No, you're good.
So yeah.
Yeah.
Not a spoiler.
I'm not gonna say what the significance of this is, but basically there was a ship in the show that some of the characters were using and flying, and it has this on it. So I'm not sure how easily that's being picked up, but basically it's a bunch of aircraft. You have a general aviation aircraft, and then that was the first one's the Wright Flyer, and then a regular Cessna kind of thing. 747, the Space Shuttle, Spaceship Two, and then some of the ships from the show. And I saw that, I was like, wait a second, because we built Spaceship Two. I have coworkers that built Spaceship Two, and I know an astronaut. I work with an astronaut that actually flew it into space and whatnot.
So freaking cool.
Blows
was like,
my mind.
So freaking cool.
That's amazing. That is so cool. Wow.
Yeah.
Like,
I showed
that
some
is an
coworkers, they're
excellent
like,
Easter egg.
no way!
That's so cool. Holy moly. Oh.
Yeah.
Oh.
I'm definitely still geeking out. Still geeking out about it a little
Yeah,
bit.
I'm over here like, whoa. That's incredible.
It's very cool. That means that in the future where the Expanse takes place, like that is acknowledged as basically one of the great ships, one of the great aircrafts that's been made, and that's freaking incredible. That's such a cool thing.
It's kind of weird to think about. But like, I was on the other side of that in the public, not long ago, like, 6 months ago, being like, oh, those people are like, incredible people, and they are, but like, they're also people, and I didn't acknowledge them as people until they were my coworkers, and I'm like talking to, one of my coworkers, oh yeah, I was there for that test, and I helped build that thing, and I made the tank for the rocket engine, and I was like, first of all, you're incredible, but also you're just like a person, and that's always good to recognize. Just like normal people doing incredible things like that. I don't know.
That's like the secret theme of this video is being human. Just the awesomeness of human.
Yeah, I think I went on like 3 tangents just in one sentence, but yeah.
I love a good tangent.
To come back to the.
Well, we are starting to get towards the hour mark, so I'm looking at our questions and wondering. No, it's okay. It's like where were we? Where were we?
I forget what question I was answering, and I went into Voyager, and then like.
How did you get this job? Like, obviously, this is where you make money now, I imagine.
Mm-hmm.
Yeah. So how did you end up here? How did that work?
So a friend of mine from Project Egress knew of this company, and he did a video at this company. And he and I were talking about careers and life and stuff. And so he said, you know what, you should apply at Scaled. They have a really cool thing that I think you would enjoy, which is basically, even as an engineer, you're very hands-on to the process. Like right at this point, I don't really know what I'm doing. So I'm still very much learning, as most people are. But if if you want to design something, basically you should be able to do it yourself to understand how to design it, first of all, but also how it should be manufactured, what the best practices are for the design, both in engineering and manufacturing and whatnot. And so, like earlier today, it's a day off. We have every other Friday off.
Nice.
Yeah, it's nice. I went into work and I just used the lathe because we're allowed to do that, and we're encouraged to do that kind of thing. And so basically, he said, yeah, you should apply there because that's what you're into. You're into the desk work of like doing CAD models and stuff, but you're also into making things with your hands, and I really enjoyed both. So yeah, I ended up applying at Scaled and got an interview over the phone, and then eventually they flew me out here, and I had an in-person interview, and then they hired me, which is super cool.
Super cool. I guess that also links back to what you were saying earlier about talking to people and making friends and like chatting, because you never know where it might lead.
Taking the chance.
Yeah.
That's
very cool. Very cool.
Mm-hmm.
I like stories with happy endings or happy middles, I suppose. Like, obviously there's not really an end here per se.
I'm done. I'm just kind of retired now.
The end of the story. I want to know if there is something you've done or worked on that you think didn't get enough recognition and you'd like to shine a little bit of a light on it. Give it a little spotlight.
Maybe, I don't know.
Just stuff you thought that was cool, but maybe people haven't seen as much.
Yeah, I guess this is kind of a simple example. I don't know, but The first thing that could be argued was on the national stage that I worked on, way before Project Egress, was for a drum corps called Legends. So drum corps are, some people are going to hate that I say this, but they're basically like higher tier marching bands. You basically have brass. You basically have brass instruments and percussion and color guard. And so color guard do like visual stuff as well as the actual members, and then you have percussionists both in the front and on the field. And this is like all done on an American football field. So they have, a lot of them have these hats called Shakos. So this is one of them from Legends from that year, 2016, I think. So this goes on your head, and you look all fancy and stuff in uniform.
It's so shiny.
They're LEDs.
Yeah.
Hey!
Super cool!
Ah, look at that!
That's awesome.
It's basically just a 9-volt battery in there. It's kind of all tucked away so it doesn't hit the person on the head. But then there's a switch in the side here that they just drilled through and mounted. I did some of the soldering for this, and I have photos maybe we can show or something, I don't know. But basically it's battery to switch to LEDs, and that's it. It was really simple. But we had to make like 150 of them. Or about 100 of them. No, yeah. So it was a lot of soldering. And then people saw that and they wanted to have their own for like their own high school marching band. So I think we eventually ended up making 500 LED circuit sets, which was a lot of fun. And made for a cool effect, I think.
Yeah, super cool. And such a cool way of modernizing, like, obviously that style of hat has been around for more than 100 years. And yeah, it's such a cool way of modernizing something while keeping it still looking, classic in a way. Yeah. Love it. That's super cool. Neat.
Do they have Australia?
Sorry?
Like drum corps?
It's definitely not as big as in America, because I know you guys do it with like lots of football games even at school and stuff. Marching bands definitely aren't as much of a thing here. I think it's more associated with military stuff. Like I'm pretty sure there are people in the military who are hired to do bandy things. Yeah. We did have a band, but it was more like a concert band at school.
Okay, yeah.
Yeah, our football's quite different to American football anyway. Yeah, we do rugby and AFL. Like we invented our own football so we could be the best at something. So we have one called AFL, which is very, very different to most other kinds of football, and then rugby, which is obviously just a big kind of like wrestling football. I don't know. It's like violent football. Without the padding, like with gridiron and stuff. So yeah, I think we do football
as many rules.
Quite different. Yeah, it's pretty brutal. People get pretty bloody. So it's a bit different, I suppose. But I think
I apologize. There's unfortunately somebody who might be screaming in the background. Yeah, no, I'm very sorry.
Awesome. That's just a good thing, I think. Okay.
Yeah.
maybe getting sleepy. Sleepy cat. So
he's beanie time. I think it's time to run around and wake everyone up. That's what time.
The Witcher.
Get the zoomies.
Probably.
Cats are a mystery to me. I think. Yeah. So
and everyone.
Yeah, that's true. Maybe themselves. Who knows? What's coming up for you? What are you focusing on the next few months?
Yeah, so I've been doing a lot of RC flying. So like, there's that bit. I have a couple of flying wings here.
And you made these.
So I'll be doing a lot of that. Yeah, I designed them. I mean, like, it's a really simple thing to design.
Simple, actual flying plane,
So like this is the first version, and I built another version, which is 10% bigger. I'm gonna drop it. Hold on. There.
Oh, that's so cool.
And this has like an aerodynamic fairing for the electronics instead of just having them out in the open.
Very cool.
But this is actually going to be done for streamer combat at my workplace. We're going to get a bunch of people outside and flying different RC airplanes, and we're going to attach like paper streamers to them, and we're going to try and cut them. And like if you cut it shorter, then you get more points or something.
So you're gonna cut other people's, really or
yeah.
What fun! Like a battle.
Yeah, exactly. Contact is also okay. Like if you just run into someone else's airplane and they go down and you're fine, then I guess you win.
Wow, it's like robot battles in the sky. This is amazing. Wow.
Yeah,
very cool.
Very cool.
So that's just on like the hobby. I mean, I guess all of this stuff is hobby anyway. But yeah, so I'll probably be building more of those. I have another one that Faye mentioned before this that kind of destroyed itself a little bit.
Yes, this is the Crashy Plane.
Yeah. So actually, this damage isn't from a crash. I spun up the motor and the prop came loose and it destroyed itself.
Oh.
So
self-destruction.
Yeah. I think I got above like 3/4 throttle and it just vibrated and tore itself off. Oops. And broke like the nose and everything. To be clear, like this also hasn't flown before either. It's crashed both times, and there are some fun videos of that.
It's the Crashy Plane.
Yeah, it's the Crashy Plane.
That's awesome.
Basically there's aerodynamics that I don't have an intuitive understanding of just yet, which is great for a person working on airplanes for a living.
You have giants all around you. You'll be fine.
Yeah.
You do understand it, because you explained stuff to me very well, and I was able to understand it, and I know nothing about making planes. So, like, you know more than
arguably neither do I. But basically, there's like weird aerodynamic stuff with aerodynamic balancing and whatnot. It wasn't right, so it was unstable.
So it wasn't like a resonance frequency thing. It was. Okay. Interesting.
Maybe for this, for the motor vibrating apart, but for when it actually flew and I crashed it properly, I think it was an aerodynamic issue where the balance was all wrong and it was tail heavy and it just kind of stalled and flipped and crashed.
And is there like
it sounded very exciting
simulations and stuff? Like, do you use like? No, you just okay, cool. I suppose
just throttle up and throw it, and if it doesn't work, I guess fix it and try again.
I like it. That makes sense.
Yeah, it was a lot better the second time. I think it went maybe 50 feet.
That's cool.
And then it went unstable and crashed. The first time, my coworker threw it and let go, and it immediately went up and fell flat onto the ground, almost hitting him.
Oh,
he was fine.
It's a boomerang,
but
it's
Yes, that's it was all shot in slow motion by another coworker, Lucas.
Oh, that makes it even better.
Yeah, so there's Eli's face after it comes back down and narrowly misses him. He's just like.
Okay, you have to send me that video. That I will have to put in the description. That sounds amazing.
The look of I just saw my life flash before my eyes.
And he's laughing, but trying not to laugh at the crash. But also he's almost died. Not really, but
too many feels all at once. Oh, that's great. That's great.
Very well. Well, I definitely think that after this, there's going to be more people interested in seeing what you are doing and what you're getting up to. So, where can people find you? Tell us where what communities you spend time in, where you're a regular, and where people can find you.
Yeah. So, generally, in social media wise, I'm on Twitter. Don't go there; it's an awful place. But also, I go there all the time, every day. So, why not? I am.
We're trying to raise the real estate a little bit. The three of us.
Yeah. I'm at Aero Engineer 16 because I made it when I was 16 and I wanted to be an aerospace engineer.
And now you are. There you go.
Yeah, actually I am. That's weird.
Full circle.
Yeah. But on Instagram I'm andrew.barth.20. And I'll send that to you so you can have an actual
thing.
Did
you make that when you were 20?
I did. I made it actually just before Project Egress, the build, because my boss at the Smithsonian said, you should probably get an Instagram before this. I was like, yeah, probably. And now I use it all the time. So,
cool.
Thanks, Meg.
Thank you, Meg.
So yeah, I also have a YouTube, which I can send you the link because I honestly do not remember what you can find it under. Because if you just search Andrew Barth, you'll get Andrew Barth Feldman, who was in Dear Evan Hansen and is not me.
Good to know. Well, we will pop that in the description. Definitely.
Yeah.
Yes. Yeah. And you sometimes come to Matt Stiltz's call too. Sometimes.
Yeah. Once in a while. I haven't as much recently, just because I've been tired.
Fair. Got a lot going on.
But I really enjoy when I do come on and talk to you guys.
Yeah.
Yeah. I hang out in Southern California at airports, so like that too.
Meet you there.
Awesome. I don't know.
Well, we'll drop all those in the description. And
sure,
is there anything else you wanted to talk about? Tell the world.
Could I just show the Tesla coil real quick, because I'm really proud of it? And
oh my god!
Yeah.
Yes.
I'm still pondering what a solid state Tesla coil is.
Do you also watch Styropyro? Oh, so cool.
So, funnily enough, I knew about Styropyro since like he started, and just before I moved here in June, I realized that he was in the same town as me. Like, like, excuse me.
All this time we could have been besties.
I want to play with Fireball lasers. But yeah, so I don't know if he has a solid state or a spark gap Tesla coil, but I know he has Tesla coils and he plays around with those. Yeah, so this is eventually going to be a solid state Tesla coil. To show the rest of it off.
Wow.
This is just a motor controller box for like a big gas stepper motor. I got it from my university's like kind of cleaning out day, because we moved buildings in the engineering department. But it's got gigantic fans, which is nice.
Important.
And it will hold high voltage things.
Also important.
Yeah, especially like if I don't want to die.
We definitely.
Preferred.
Yeah.
Preferred if you don't.
Yeah, me too. Yeah.
That's very, very cool.
But I just really like the copper. This is just a couple hundred turns of 26 gauge copper wire.
Of course, yeah. I don't know why, but I was thinking it was flat. But of course, it's a coil. Yeah, that's beautiful. It looks flat because it's so neat.
Yeah, no, it literally looks like a giant just copper extrusion, copper pipe.
That's beautiful.
Yeah.
Like it looks perfectly smooth. Wow.
Yeah. And then this is just a bunch of aluminum tape on a piece of styrofoam. It's a styrofoam Taurus from Walmart, I think, and then a piece of foam board in the middle. I just wrapped it all with foam or with aluminum foil tape. And then there's like a little pad on the top for it to connect to electrically.
Nice.
But yeah,
that's cool.
Basically, I don't know. Do you know how like Tesla coils work, or want to know?
Tell us. I only know very vaguely.
Okay.
I know a little bit. But
when I was in school, which was many, many moons ago now. So, yes. Tell us.
Put this back. Oh no. Cool. My headphone cord is not that long. So basically, you have two separate circuits. You have the driving circuit and then the excited circuit, I guess. So there was a big coil of wire on the bottom that was like insulated black coil of wire, and that goes to the driving circuit. Basically, you have this set of switches. I think they're generally MOSFETs or IGBTs. Yeah, that sounds right. So basically, you're switching moderately high voltage, like wall outlet voltage. At least here, it's 120 volts. There, it's 220 or 240-ish in that range. So you're switching wall mains outlet voltage, and you're basically creating a square wave alternating current through that coil. But the whole system has a resonance associated with it. There's like some fun physics going on with that. So you're driving it at, I think for this one, like 300 kilohertz, and you're trying to match the resonant frequency of the big coil by driving that big coil with a smaller coil. And when you achieve a resonant frequency, then you can actually get more efficient transfer of power through. I'm sorry, I'm going into so many tangents.
No,
This is an
cool.
air core transformer. So basically, you get better coupling from the low voltage side to the high voltage side, and you can get better output and whatnot, which means longer sparks. But I think I had 6 turns of that smaller, of the lower coil, and I have something like 700 turns of the main one. It's called the secondary coil and the primary coil. So there's like a ratio there that determines what the output voltage would be, and it should be like 50 to 200,000 volts or so, coming out in sparks of varying length. And then if you turn that on and off really fast, not as fast as the actual driving frequency, but like around 440 hertz or so, then you get a concert A, and you can actually play music with it. So if you then feed, if you then feed musical signals to it, then you can actually play music and whatnot. But you also have to be careful because you're generally overdriving all the electronics, and you're counting on the fact that you're not having it on too long to make sure it doesn't blow itself up. Because I think the MOSFETs I'm using are rated to like 20 amps or something like that continuous, and I'm putting like 100 through it for a short amount of time. So if you put 100 amps for 10% of the time, then you get about 10 amps continuous-ish, but also not really. So you just have to be careful. There's all kinds of things to worry about that I do and don't understand. And that's kind of where I'm hitting a snag with the whole project. It wasn't quite working and things were blowing up. But
good time
sure,
to let that rest for a little while and come back to it later.
Yeah, I'm just going to ignore it.
Yeah.
Know.
You are very smart.
Very, very cool.
You were very, very smart. Very cool. So much of that went over my head. I'm just.
Me too.
I'm like, I remember square waves. I remember resonance frequency. I understand some of these words, and then but together, mystery.
Admittedly, this is very much how I feel reading Japanese, where I'm just like, yeah, I know some of these words, and I can kind of string them together into something that sort of makes sense, but I'm missing whole chunks of things in the middle. So yeah, it was a bit like that.
Basically,
you were so smart, though.
Thank you. I guess there's a really good analogy with like a swing set and pushing someone on the swing set for resonance. So basically, like the swing set, a person on the swing is a pendulum, and so they have a frequency at which they want to go back and forth. And if you're like a parent or something pushing your kid on a swing, you want to push at the right frequency. You want to push when they're at the right spot. And if you just like push them some other time when they're on the other side, and then when they're in the middle, it's not going to work. They're not going to go higher. You're probably going to slow them down, and they're just going to like be bored. But if you push at the right time, then you can actually increase the amplitude, and you're adding energy every time, so then you can get the person on the swing really high, even though you're inputting not that much energy.
Actually, that was an excellent visual. I feel like I understand it so much better now.
Yeah,
I'm like,
and so,
okay. Swing set.
They multiply.
Actually, that makes sense.
If you get two waves going at the very same, then they just like add together, and you get double the heights and double the troughs.
Yeah, exactly.
Yeah.
That's constructive interference. Yeah. And then as far as what's called the duty cycle, which is the on versus off, like you as a person probably cannot be pushing a swing set 24 hours a day for a whole year. You would just like probably die because you got to eat sometime, and you got to live. So if you do it every week or so, or even every day for 10 minutes, then you're fine. But if you do it continuously, then you burn out and you have problems. So the same thing happens with Tesla coil electronics. You have to only have that system on for part of the time, and then you switch it off for most of the time, so it can kind of cool down and recover, and then you switch it on again for 10% of the time, and then you cool down again. So that's the other side of things that you have to worry about. It's just with a swing, like it'll take a while for you to get burned out. With this, it'll take a couple milliseconds to blow up. So you have to like be on top of it.
It's like a Tamagotchi on steroids.
Yeah.
Oh
Yeah.
gosh, that feels
Really
like
fast.
the perfect place to just like the visual of the Tamagotchi and steroids. That feels like such a perfect place to leave things off. It's like the visual.
Just leave you with that.
Absolutely perfect. Thank you so much, Andrew, for agreeing to come
Yeah.
and hang out with us and to share your story with everyone who's watching, because it is genuinely really, really cool, and I'm really glad that we get to help get it out there. So
Well,
thank you so much for coming on with us today.
Thank you both for having me.
It's definitely my
Yeah,
pleasure.
I mean, like, is it night, day, mid-afternoon?
It is
in
literally
3 different
all
time
three.
zones around the world. Yeah,
Yeah.
it's it's 4:30 here in the afternoon.
And 9:30 a.m. here, and very, very late for more, dear Faye.
Yeah.
11:30 p.m.
Ooh.
So.
Thank you, Faye.
Yep.
Thank you.
Yes. Thank you so much, Andrew.
Okay,
This
you
was
saw
really
you saw the
wonderful.
cat alarm come in.
That's true.
That was the go to bed, mom. Mom, it's bedtime. I do apologize. As he very much interrupted your very good explanation of your plane, which
I
is to
couldn't hear
come
it.
up on the desk and scream. So that was like, okay, thank you, cat. Thank you. Well done. But yes, thank you so much for coming and being our fourth guest.
Sharing all your cool and wisdoms with us.
Yeah.
And seriously, it was incredible. So thank you so much.
Thank you.
It was awesome. Yes. And we'll
Thank
see
you.
you on the internet.
All right. See you around.
Bye. Oh, thank you. That's awesome. I am loving making this series, and if you are too, please support me on Patreon so I can keep making more. Top supporters will appear in this list of legends. You can meet another maker here, and here's a video YouTube thinks you'll like. If you want to catch up with any of us, all our socials are in the description below. See you later!